In this video I'm going to be looking at finding the hypotenuse, which is the longest side of the triangle, using Pythagoras' theorem. And this is Pythagoras' theorem here. The first thing you need to do is make sure you've got a right angled triangle, which we have, because that little square in the corner means it's a right angle. Then I need to label my triangle. The longest side is always C. The other two sides are A and B. And it doesn't matter which one is A and which one is B. In this example, you can see that the two short sides, A and B, have got sides of length 3 and 4. C is the one we don't know, and that's the one we're going to calculate using Pythagoras' theorem. So we're going to be going through the same steps all the time. We write the formula. We substitute the numbers that we know. In this case, we know that the number for A and the number for B, and we make the unknown C the subject. So let's do that. So first of all, let's substitute. Because A is 3, I'm going to write 3 squared. And B is 4, so I'm going to write 4 squared. I don't know what C is, so I leave C squared like that. So you can see that A has changed into 3. I've substituted 3 for A. B has been substituted by 4, and C we didn't know, so we left it there. This formula is telling me how to work out the answer. All I need to do is be able to use algebra and a bit of solving of equations. So what I do now is I look at what I've got and see if I can solve any of the bits that I know. Well, I know what 3 squared is, that's 9, so I can change that into 9. And I know what 4 squared is, that's 16. Well, I can't do anything with C squared yet, so I'll leave it there. 9 and 16 make 25, so I can write 25 equals C squared. Now, I'm nearly there, because what I need to have is just C equals a number. What's stopping it being by itself, what's stopping C being the subject, is this squared. To get rid of a squared, you need to do the opposite, the inverse of squaring. And the inverse of squaring is square root. So when you have an equation, you must do the same thing to both sides of the equation, otherwise it's no longer equal. So if I'm going to square root C squared, because it's the opposite of squaring, I need to square root both sides of the equation. And you can see I've done this square root symbol to both sides of the equal sign. That means I have not changed the equation, I've not mucked up the equalness of the equation. It's still equal. Now, when I do that, square root of 25 is 5, because 5 times 5 is 25. The square root of C squared is C, and that's the reason we did it. We wanted to get rid of this squared, so we used the inverse. The square root of a square, they cancel each other out in effect, and I end up with C. C squared and square rooted is C. For those of you who are a bit not sure about what happened with that C squared and square root, let's give you an example to illustrate it. If I've got 5 and I square it, I get 25. If I do the square root of 25, I get back to 5. So starting off with 5 and squaring it's 25, square rooting at 25 gets me back to 5. So I started with 5 and I ended up with 5 when I squared and then square rooted. So over here, squaring and square rooting, they are opposites, and that means they cancel out and I end up with just C left. On the left hand side, the square root of 25 is 5. So C is equal to 5. That means that this side over here has a length of 5 metres. Here's another example. In this one here, I've got another triangle. It's a right angle triangle because I can see the right angle in the corner. It's got 3 sides, so it's a triangle. And if I look at it, I've got a hypotenuse and 2 other shorter sides. So let's label it again. This side will be C. It's the longest side. The longest side not touching this right angle, which is opposite the right angle, is always C. I can label the other 2 A and B, and then I'm ready to go. So the next thing to do is to substitute. But when I look at it, oh, there's a bit of a tricky bit here. This one's in centimetres, and that's in metres. I need to use the same units. It's no good having centimetres and metres. They need to be both metres or both centimetres. So I'm going to change this one into 0.3 metres. Now I'm ready to go. So looking at the equation, I've got a squared plus b squared equals c squared. So a is 0.6, so substituting in, I get 0.6 squared. B is 0.3, so that's 0.3 squared. And C we don't know. 0.6 squared is 0.36. 0.3 squared is 0.09, and that's equal to C squared. Now if I add those two numbers on the left together, I'm going to get 0.45. So that's equal to C squared. To find C, I need to get rid of the square root sign. So I'm going to do square root of both sides. On the right hand side, C squared square rooted ends up being C. And on the left hand side, the square root of 0.45 is 0.671, and I've rounded that off to 3 figures. So that will be also metres. So I found out that this side here, C, is 0.671 metres.